quickly go over how to be solving systems of linear equations with two equations, and we're going to be talking about all possible cases of this. So there's really only 3 different possible scenarios that you can have. So in order to talk about this, let's set up our system. So we have y1 equals m1 x1 plus b1 and y2 equals m2 x2 plus b2. And okay, so let's start picking this apart. So if we have a situation where m1 equals m2 and b1 does not equal b2, then we're going to have a situation like this. And notice how the equations are spread apart. So this could be y1, y2 on the xy plane, and there's going to be a gap there between, the distance between these equations is going to be represented by the difference between b1 and b2, or by subtracting those. So yeah, so if this is what we have, then we know that m1 equals m2 implies that it's parallel. As long as the intercepts don't equal, then in that case we're going to have no solutions, because the lines are never going to cross, so they can't meet at any points. But if we have another situation where m1 equals m2 and b1 equals b2, then in that case, by definition, these are going to be equivalent lines. Or another way to describe that is they're coincident. And if this is the case, then we're going to have an infinite amount of solutions, because notice what's going to happen here. We're going to have our y1, but if we go to plot y2, they're going to have the same values to make up the same equation. So that's also going to be y2, and they're stacked on top of each other. So they're going to share all the same points, so an infinite amount of solutions. And so what if we have, if m1 does not equal m2, then well, in that case it's going to cross at exactly 1 point. So one solution, and we can make a couple sub cases of this. So for example, if we have something like this, where they would intersect in the y intercept here, then this would be the case where let's put our y1 and y2, then in this case we would be able to say that b1 equals b2, and they're still going to cross in one place, but that place is going to be at the intercept, the y-intercept. So but we could also have a situation like this where it's going to cross at some px comma y, and putting our y1 and y2 here. So it's going to shift all the way away from crossing at the y-axis, then this would be a case where b1 does not equal b2 as a sub-case of the m1 does not equal m2. And notice how by construction, these are the only possible cases that we can come up with here, because if we try and make like two solutions, for example, since the lines completely diverge away from each other, the only way to get more than one solution is to merge it so it stacks on top, but then we would have infinite solutions. So really, these are the only possible scenarios that you can have. So yeah, hopefully you found this helpful, and come back for the next one where Joe shows you how.